Hi, my name is Brisa, and today I'll be sharing on comparison of costs in a free choice foraging task. To start off, I think it may be helpful to relate the overarching idea that we tested in the study to something perhaps some of you may have encountered before. Say if you had a really busy week, whether it was work or school, it was so hectic that you've been neglecting the state of your house a little bit. After getting home from a long day, you receive a call from your friend. They tell you that they are close to your place and were considering stopping by. You agree, and they tell you that they'll be there in 5 minutes. Looking around your place, now you have a decision to make. What do you clean? Do you prioritize cleaning your living room and hope she won't see the kitchen? Or do you clean the kitchen and hope she won't suggest moving to the couch? Remember, you only have 5 minutes. Decisions like this occur every day, and for most species, these decisions are more essential to their survival and less so about a sense of embarrassment from an untidy place. Nevertheless, decisions under different constraints depend on the appropriate allocation of time and energy. A common way of studying the occurrence of decision-making is through patch foraging. In patch foraging, animals forage for food among different resource-rich environments, or what we call patches. Thus, animals should adopt a foraging strategy to optimize their food intake when under a time constraint. This is exactly what a mathematical model of foraging behavior tries to explain. Visualized here to the right, it is known as the marginal value theorem, and it suggests that the optimal food intake is maintained by leaving the current patch when the reward rate drops below the average rate of food intake across all patches. With this model as our background, the present study aimed to further investigate the effects of varied costs like effort requirements, travel time, and food availability on foraging behaviors in a free choice foraging task. Utilizing 10 long Evans rats, we employed a patch foraging task with the presentation of 2 free choice field arenas separated by a middle corridor. And shown here at the very bottom, you can see the 2 arenas to the left and the middle corridor in the middle. And it's important to also highlight that these were free choice, meaning that the rats could, at their own discretion, pick whether to enter patch 1 or patch 2, when to leave and when to come back. Additionally, each patch released remotely sugar pellets that started releasing upon entry to the patch and also had a decaying rate. And this interpellet interval increased with patch duration to mimic harvest depletion. It's also important for the study to note that rats could reset the reward rate by leaving and returning to a patch, although they could face effort or travel cost. In other words, a rat could continue to stay in a richer patch through the whole session by resetting the reward rate once the interpellet interval denoted a depletion. And shown here again at the bottom to the right, we have the variables that we really wanted to control for. We had our 4 food reward rates, what we called our lambdas, and it really just showed the richer versus poor environments that a rat could encounter within any of the sessions. And then all 4 of those were included in our effort task, where there was a low effort, which meant that there was no hurdle that they had to climb over, or a high effort where they had to climb a 30-centimeter hurdle to get into a patch. And then our time travel in the middle corridor, they had to wait in there for 5 seconds or 60 seconds, just to kind of vary the time that it would take to travel to different patches in the wild. As expected and consistent with the marginal value theorem, behavioral analysis demonstrated longer residence times when tasks required a high effort or a long travel time, where residence times here means the duration of a rat in a given patch. Additionally, we also had an interest in investigating the effect of food availability, which we denoted as our food reward rates, or our lambdas, or also our interpellet interval rates on foraging decision making. And as shown here, our correlation plots for lambda index values showed a significant effect on patch preference as the difference between those 2 little curves grew further apart. Furthermore, the interpellet interval, again our lambdas or our food reward rates, also had a significant effect on residence times for both effort and travel time conditions, which we can see here at the graphs below, where richer environments denoted by the 16s, richer environments had higher residence times for both the low effort, high effort, short travel time, and long travel time. The results from the present study align with foraging theories by reflecting behaviors that are expected for an optimal food intake rate in a patch foraging. However, not aligned with such theories is a pattern of alternation the rats exhibited across sessions. Rats used for the study had been previously trained in tasks where reward rates could also be reset by leaving and returning to the patch, yet many of our rats did not display this behavior and often foraged in the opposite patch in varied but shorter durations before coming back to the richer patch. This was a really interesting finding as it challenges our understanding of foraging strategies rats may be using for optimal decision making. Future studies should pay special attention to this and aim to account for this behavior into foraging theories. In conclusion, we established that appropriate decision making is critical for many species. The present study further aimed to shed light on the factors that influence decision making by utilizing a patch foraging task that compared between tasks with effort and time constraints, as well as full availability between patches. As predicted by foraging theories such as the marginal value theorem, rats stayed longer at patches with richer food availability when they had to incur costs such as effort requirement and a long travel time. Interestingly, rats demonstrated an alternation between patches across sessions. Further studies should seek to account for this behavior. Acknowledgements to the PROPS program for allowing me this opportunity to carry out this independent research, and thank you so much.